Everybody's doing all right. As always, we're just waiting for everybody to get connected fully, and then we will get started.
Good morning.
Good morning. Good morning.
What was that factor video called?
I just have to send it. I have to find one of our videos that I talked about factoring, and I'll just send it to you. Um, did you send me an email on that?
Yeah.
Okay, so give me a chance. I got to get caught up. I got flooded with emails within the last day or so, so I got to get caught up on my email. So I'll send it to you today. All right. Good morning. Good morning. Okay. So I don't see one person still connected, but so I'm pretty sure they'll get on. So as I said before, good morning to everyone. Hope all is well. Hope everybody's doing all right. Hope everybody's ready to get the weekend started. You know, our weekend starts Thursday, right? Because we're gonna come back to tomorrow. So we'll go ahead and get into our next section. I believe that is 1-3. Yeah, we did 1-2 last class. So looking at 1-3 models and applications. And let me see what was 1-4. Probably look at 1-4 too, just complex numbers. But yeah. All right. And as far as let's say if you missed last class, I will be shooting those videos out sometime tomorrow. Like I said, I convert video, record all the lectures, convert the videos to YouTube, and shoot the link out to you guys so you have them to be able to review. So just give me a day or so to go ahead and get all those in, and then I'll shoot them to you. So today we start with 1.3 models and applications. Applications is just another word for word problems. I know a lot of people don't want to hear that, but yeah, that's what this section is dealing with word problems. So strategies first, you want to read the problem. Of course, you want to read it. Make sure you understand what the problem is saying to you. Make sure you understand what it's asking of you, and read as many times as it takes in order to get the understanding that you need to move forward. Then, if necessary, you're going to write each unknown in terms of one variable. So the reason why I said if necessary, sometimes you'll have one unknown, but if you have more than one unknown, what you do not want to do is to call one of them X, the other one Y, and another one Z if you had three unknowns. So we want to write all of them in terms of one variable. The more variables you introduce, the more equations you're going to need in order to be able to solve. So you will have to create a system of equations, which is what we're not trying to do in this section. So every problem you get, you will be able to write all of your all of your unknowns in terms of one variable. Then you write an equation, solve that equation, and then check. And so when you look at step 3, writing that equation, your equation will be based on keywords that are in the problem. So we'll talk about that when we get there in a second. Notice I put asterisks beside the steps 2 and 3. That's because those will be your most challenging steps. Um, the parts that really you'll have to focus on making sure you establish those correctly in order to get the correct answer. Once you solve, you do want to check to make sure you have at least answered the question. Sometimes you can come down and solve, have your solution for the variable you created, but you didn't actually answer the question. So you have to make sure you actually answer the question. All right. Can I scroll up? As always, or as I mentioned last class, if ever I scroll up and you're still copying, feel free to let me know whether you unmute or just type it in the chat.
What was this section called again?
1.3 is models and applications.
Thank you.
Mm-hmm. All right, so here's the first work problem. So the average yearly salary of a man with a bachelor's degree exceeds that of a man with an associate's degree by $25,000. If you notice right here, I left out average, so that's why I wrote it that way. The average yearly salary of a man with a master's degree exceeds that of a man with an associate's degree $45,000. Combined, they earned $214,000. Find the yearly salary of each. So let me erase some of these lines. Don't need them right now. So give you guys a chance to write. For those who are going to write this down, and then we'll get to the problem. All right, so when we're looking at this problem, we have multiple unknowns in this problem. We have 3 unknowns. If I were to put my lines back, so we have the man with a bachelor's degree, the man with an associate's degree, then the man with a master's degree. So we have 3 unknowns. So we want to write each one of those unknowns in terms of one variable. So let's say we decide to use X. We don't want to use X for the bachelor's degree, Y for associates, and Z for masters. We want to write all of them in terms of X. So if you notice, both the bachelor's and the master's are described in terms of the associate's degree. So we can write them in terms of that. So watch what I did here. Let me erase this stuff. So my associate's degree, I decided to let that be X. No, we right here. Associate's degree, I decided to let that be X. Now, the bachelor's degree exceeds that of an associate's degree by $25,000. So I called that one X plus 25. If you exceed somebody or you make more than $25 more, $25,000 more than me, then no matter what I have, it's going to be what I have plus 25,000. And we're writing it in terms of thousands, so I just dropped the thousand part. So we're doing 25. And then with the master's, the same type of relationship. It exceeds that of a man with an associate's by 45,000. So that's how we got those representations of our unknowns. Questions on that setup right there before we go any further? Step 2. You call one of your unknowns X, and then you write the other ones in terms of that X.
So adding the thousands doesn't matter?
No, because it's just in terms of thousands. Notice how they did it right here. They just write 25 and then the word thousands. And so everything is described in thousands.
Okay.
Now, if they had 25 with the 3 zeros, then you know you have to include the 3 zeros. All right. So now okay, go ahead.
Is that the same for every problem, the 1,000 thing, or like?
Well, yeah, yes. If it's written like that, yes, you don't have to include it. But once again, if in the problem they write 25 with 3 zeros, then you need to include your 3 zeros. Yep. All right. So, and then the next piece is to set up our equation. Our keyword here is combined. So notice what we did right here. And one of my parentheses are not there. We took all 3 of our salaries. We have X plus 25, and X plus 45. We add them together because it says combined. They earn 214. So we add them together and then set them equal to 214. Any questions on that? Make sure that that's okay before we move forward. All right, we good. So then from there, you go ahead and solve like we did last section. So those parentheses aren't needed. I just used them to signify, what, was added together, what came from what. So you can drop those parentheses and just add them together, combining your like terms. We have 3 X's, and then we add 25 and 45. So that result is right here, 3x plus 70. Then we would subtract 70 from both sides. Oh, let me do that. That'll give us 3x equal to 144. Then to finish it off, divide by 3. X is equal to 48. All right. Any questions?
Where'd you get 214 from?
Right here. Yep, together they earn 214.
Oh, okay.
All right, everybody good before we go to the next piece? That's straight. All right, so now we have to ask ourselves, did we answer the question? Notice that last statement says find the yearly salary of each. So if all I have is x equal to 44, I didn't find the yearly salary of each. So you do need to go back and, like I said, always review and ask yourself, did you answer the question? So this is a classic example of us setting up our variables, setting up our equation, solving our equation, having a solution, but we still didn't answer the question. All right. So we go back and plug in 48 into each one of these spots where x is located. So the associates, man with associates earn $48,000. Man with bachelor's is 48 plus 25. So that'd be 73. And then here, 48 plus 45, which is 93. And those would be your three salaries. And don't forget, all three of those should add up to give you 214. If they don't, then somewhere, we went wrong.
And this all represents into the thousands, right?
Yes. So my math lab will let you know if you need to, need to do anything different. If you had something like this, but 48, 73, 93 should be good enough. And like I said, the only reason that that's the case is because the way they set it up in the problem by just writing 45, but then the word thousand instead of writing 45 and, the 3 zeros.
Gotcha. Thank you.
Mm-hmm. All right. Any questions before we go to another one? Just a heads up. Don't know if it's going to conflict with us or mess with us. Our pest control guy that was supposed to be coming between 8 and 12, and of course, they didn't come until they haven't come yet. So they're probably going to show up during the time that you guys have class. So I just got to open the door and let them, yeah. So one of those joys of working from home, right? All right. So let's look at this next one. Your local computer store is having a sale on cameras. I can write sale better. After a 40% price reduction, you purchased a camera for $276. What was the camera's price before price reduction? How's the chat not popping up? Oh, didn't mean to do that. Sorry, guys. All right, there you go. Right, they never show up. Look, I get 3 hours. They didn't show up, but they're gonna come in during the class. Absolutely correct. So make sure you guys get a chance to write this down before I go in there. So when you think about this problem, think about retail. Even if you've never worked retail, I remember I used to work at Target back in the day. But even if you've never worked at retail, you know there's a certain way that this has to happen. In order for a sale to occur, you know, you had to have an original price. Then there has to be a discount. So the original price minus your discount is going to give you the sale price, right? There's no other way to get a sale price other than having an original amount, a discount, subtract the two, then you have your sale price, right? So that's going to be our setup for this type of equation. We have our original price minus the price reduction, and that's going to be equal to our sale price. So we need an algebraic representation for each one of these three pieces. All right. The easiest piece, let me see if I can fix this. Yep. So the easiest piece that's going to be set up for us is the sale price. We already know the sale price is $276. All right. We don't know the original price. We want to know the original price, so we can just call the original price X. So now the piece, when it comes to this equation, is the part that a lot of people mess up on. So I want to make sure we're clear on how we do this, and that's the price reduction. So as I wrote right here, whenever you're looking at a percentage, whenever you're doing your calculation, which percentage, you want to convert it to a decimal first, and that's just moving your decimal 2 places to the left. So that 40% is 0.40. Now, your percentage very rarely stands alone. In other words, you're taking a percentage of something. So in other words, I wouldn't write X minus 0.40 right here. I need something else, percentages of application. And of means multiplication. So if we have an original price, I would be taking 40% of the original price. So the way I set up the price reduction is that I would do 0.40x. And like I said, of means multiplication. So that's 0.40, or that's 40% times the original price. And remember, our original price is X. So that's why we multiply that 0.4 times X. So questions on the setup before we go any further?
So you said of represents multiplication?
Yes.
Okay.
Mm-hmm. So whenever if you use the word of mathematically, you should be multiplying.
All right, thank you.
Mm-hmm. All right. So the next step throws people for a loop a little bit as well. So if we had, let's say if we had, let me go over here. Yeah, I got a little space. If I have 5x minus x equal to 276, the first thing I would do is combine my like terms, right? Add or subtract my terms together. And so that's the same thing we do here. We're going to combine these like terms. But what we have to remember is that there is a 1 in front of this x. So actually, I'm doing 1 minus 0.4. And so, like I said, a lot of times people, miss that a little bit. But this should be 1 minus 0.4. And I know somebody asked me in the past, well, show me a reminder how to do that. But so, most of you are going to be doing stuff in your calculator. But it should be, when you do 1 minus 0.4, that's going to be 0.6x. So that's 0.6x equal to 276. And then when you divide both sides by 0.6, you get 460. And so your original price is going to be 460. And so in this case, this actually ends up being the answer that we're looking for. All we want to know, what was the original price? And it was 460. All right, questions, any questions? And so some of the stuff or some questions may not even come up until you actually get in there. And I do understand that. Don't forget, every day is an opportunity for questions. We have, 2 hours that we each have set aside for this class. I don't plan on lecturing for 2 hours. So there will be room for you to answer or ask questions. So always keep that in mind. Also, if you have questions on word problems, especially, make sure you notate or bring that question to class, because I can bring up 2 or 3 word problems, show you how to do them, and it still may not address the issue you had with the word problem that you were actually dealing with. So, make sure, whether it be, notating them that in my math lab 1.3, it was number 4, something like that. So we'll know which word problem, the type of word problem you were dealing with, so we can address that one specifically. All right, let's look at the next one. So your grandmother needs help. She wants, or she has $50,000. So you see, this time we're actually using the three zeros. So we're going to keep them. So she has $50,000 to invest. Part of this is to be invested in non-insured bonds paying 15% annual interest. The rest of this money is to be invested in a government-insured COD paying 7% annual interest. She needs $6,000 in extra income from the investments. How much should she or should be placed in each? So I'll give you guys a chance to write that down. All right.
Could we have like 1 more minute to write this down?
Absolutely not.
Sorry.
Yeah. I'll give you that.
Would the $50,000 be what's put into 7% and 15%, not the 6,000, because that's what she needs?
Right. So we're gonna have to break this up. But see, the thing about it is we don't know how much to put in one account and how much of the 50,000 to put in the other account. So that's the challenge of this problem. How much do you put in the 15% account? How much do you put in the 7% account? And so we're trying to figure out, in order for her to actually have $6,000 in extra income. Yeah. All right. So are we okay to get started? I know everybody good. All right. Let me see if I put this. Okay. Yeah. So I kind of did part of this a little backwards. You'll see what I mean in a second. So what I mean by that is that this, before we look at the red part, I want to go here to the blue part, is that this problem is leaning on our simple interest formula relationship, I equal to PRT. So P is your principal, that's your deposit or loan. R is your rate, and then T is your time. So like I said, before you look at anything in red, we're looking at this blue part here. So we need to figure out all 3 pieces for each account that we're dealing with. How much we're going to deposit, which is our principal. We know the rate, and then we have to look at what time, how much time we're looking to put into this account. Okay, so copy this blue part first, and then we'll scroll back up to the red. All right. So whenever you have a problem like this, notice all it gave us was a total. It didn't tell us a percentage of the total to go in this account, percentage of this to go in this account. We can't assume that we're going to do half and half. You're not supposed to assume that I'm just going to put all of it into 15% because 15% or majority of it, you have to do it according to what she's trying to get. She's trying to get 6,000. So how much do you put in the 15%? How much do you put in the 7%? So R is fixed for us. Like I said, that's 15% for this account, 7% for this account, and the time is going to be fixed as well. So it says, where was it in here? To be invested, extra income from the investment. So we're talking about in a year where it go and look for the keyword part of this to be invested. The rest of this money to be invested. Annual interest. So we're just looking at annually after the interest is applied, you know, how much is in the account or how much will you receive. So we're just looking at 1 year. They didn't state anything else but this 1 year, earning how much money will she earn in a year. So that's why the time is 1 year for both of them. So now the key here is this piece, the principal, how much we're going to deposit. All you would do is you would call one of them X, just like we talked about before. You call one of your unknowns X. Then you write the other one in terms of X. Well, in this case, we have the total, which is 50,000, and we're going to minus X from that. So whenever all you have is the total, and you have these two, whether it be two accounts or two categories, and you want to split up the total, you will let one of them be X, and then you will let the other one be the total minus X. And that will always work. It doesn't matter which one. I could have put 7% X, and then 50,000 minus X under the 15% category. After you do all the work, you'll still have the same two answers. So, any questions on the setup with our PRT, where we got our stuff from? Make sure we're good. All right. Everybody done copying that before we go any further? All right, so our equation. So remember, whenever you multiply P times R times T, that will be your interest earned. And I didn't put that here, but I should have. So I is equal to interest earned. All right, so whenever you multiply P times R times T, that's going to calculate your interest earned for that time period. So we're just talking about a year here. So the total interest earned is going to be equal to the interest earned in your 15% account plus the interest earned at the 7% account. So that's what this red box here is stating for us. That's our equation. We have our interest total is going to be equal to the 15% amount, a 15% account interest earned plus the 7% account interest earned. All right, so we already know the interest total. We want it to total up to $6,000. That's what we want. That's the goal. That's why we're doing all this calculation. We want our total to add up to 6,000. All right, somebody saying something in chat. Oh, it's not a problem. Not a problem at all. So now, interest earned in the 15% account, we're going to multiply P times R times T. That's X times 0.15 times 1. Remember, 15% convert to a decimal first before you do your calculation. Move your decimal 2 places to the left. 15% will be 0.15. So X times 0.15 times 1 is 0.15X. Then the 7% account. The P there was 50,000 minus X. R is 0.07. And once again, T is 1. So multiplying those three together, I will go ahead to simplify, go ahead and distribute that 0.07. And that gives us 3,500 minus 0.07x. All right, any problems? Is everybody okay with what we're doing? All right, so now we're gonna go ahead and do this up here. Where we got 6,000 is our total that we want. Gonna add our, let me go ahead and move some of this stuff out of the way. Add our two interest totals together. So that's 0.15x plus 3,500 minus the 0.07x. I just put these red parentheses here just to show you that this came from this account, this came from this account, but they aren't needed. Combine your like terms. So we have 0.15x minus the 0.7x, and that gives us 0.08x plus 3,500. Then from there, we will minus 3,500. So that will be 0.08x equal to 2,500. Then divide by 0.08. X is equal to 31,250. Any problems before we finish it off? All right, so X is equal to 31,250. Remember, you always got to go back, make sure you answer the question. Remember, we want to know how much money we would put in each account. So X is equal to 31,250. And then you take that 31,250 minus 50,000. And that will be 18,750.
Real quick, sir, why would you subtract that from the 50,000 to get the 7% account?
Well, that goes back to our setup we have right here. So X was, when we solved and got down X was going to be the amount in the 15%. But we initially said, in part of our setup as well, that once I solved down the X to figure out how much was in our 7%, we would have to subtract it from the 50,000. And remember, 50,000 was our total amount.
Yeah, that's right. I forgot. Thank you.
Yeah, no problem. Not a problem at all. All right. Anybody else before we do another one? I know y'all loving this word problems, man. I had to give you another one. All right, can we scroll up? Good. All right. So the next one, length of American football field is 200 feet more than the width. If the perimeter of the field is 1,040 feet, what are the dimensions? Guess I'm going to erase that dude out of there. All right, so we're looking at the length of this American football field. A football field is rectangular. So when we talk about the dimensions, we are talking about width and length. All right, and once again, we have two unknowns. We want to know what are the dimensions. We have two unknowns, and let me see. Yeah, we can start right here. We have two unknowns, and we want to use one variable. And so what we do know is the relationship between the two dimensions is that the length is 200 feet more than the width. And so that's why I have my pieces set up this way. I call them my width X. And then whatever X comes out to be, if I add 200 to it, then I will have the length. All right. Any problems with that? Everybody good? So the next piece of this is that our perimeter. Perimeter is adding up all of your sides. But if you want to do the perimeter formula for a rectangle is P equal to 2L plus 2W. And so that's what we have right here. Erase some of this stuff.
If we didn't like remember this, like in like math labs or anything, would like they give us the equation, or are we supposed to know this off the dome?
Yeah, well now when you hit the help button, it should give you that formula in there. Yep. Yeah, so when you hit that help me solve this, well not help me solve this, well you can do help me solve this if you want to, but like I said, it won't give you credit. But if you view an example, it should walk you through a problem very similar to what you're dealing with, and you should see the formula in there. Yeah.
How about during like a test?
Now, a test, I expect you to have gone through, like, I don't give you anything in the test that you haven't seen in the homework. And so, and I'm also going to give you a test review that will be very similar to the test. You know what I mean? So if you, I guess you could say, do your due diligence, you will be, properly prepared. Like you wouldn't see a formula that you would, wouldn't have came across already. So, especially like I said, if you look at the test review are created to help streamline your studies so that you're not being exposed to that type of situation of not knowing, the formula. Yeah. So you'll be straight.
Thanks.
Yep, not a problem. All right. And then especially with this first test, because this first test you can do on your own time without me, around. So, you can just set your stuff up and just, take your time. And it's not timed. So you have your time to, do whatever looking up you want to look up. So, so I'm assuming you're talking for a proctored test, because if it's not proctored, if I'm not looking at you, there's no way for me to govern that. But yeah, so if you're talking about a test that's being proctored, then yeah, I would probably let you guys use notes. Just remember that though, if it's proctored, then you only got a certain amount of time. So you make sure you streamline, have your notes in order so that you can, look at them, flip through them accordingly and go from there. All right. So using our perimeter formula, somebody else said something in chat. Oh, yep, not a problem at all. So going to our perimeter formula, we know what L is, or we have an algebraic representation for L and algebraic representation for W. So we'll go ahead and plug those in. And that's what we did right here. So X plus 200 for L. And, oh, all right. And then X, we plug it in for W. From there, we can go ahead and distribute. Let's see if I did it right when I did this other thing. Nope, I didn't. Okay, so we can go ahead and distribute. 2 times X, 2 times 200. So that's 2X plus 400 plus 2X. Combine your like terms, 2X and 2X. We'll give you this 4X right here. Then subtract 400. So that'll be 4X equal to 64. That's 64. 4X equal to 640. And then finish it off by dividing by 4. X is equal to 160.
Quick question. Did we get the 2 from the formula for the perimeter?
Yes. Yep. These twos right here are a part of the formula. Mm-hmm. All right. So from there, remember they wanted us to find the dimensions. So we need to find width and length. So x is equal to 160. Remember we said that x is going to represent our width, and then add 200 to that. That will be our length. And so that's why we have our width at 160, length at 360. And those will be your two answers. Any questions? All right, can I scroll up? So when it comes to word problems, try them out. See if you have any issues. That's the blueprint as to how you want to attack your word problems. Of course, you want to read them, and you want to make sure that you have a variable or algebraic representation for each unknown. Set up your equation, solve your equation, and make sure you actually answer the question. And so, like I said, try these out. If you have any questions on anything, then we can look into help you out with that. Next thing in this section is solving for a specified variable. Excuse me. So let's say if we have that perimeter formula, P equal to 2L plus 2W, and we want to solve for L. So the goal is to get L by itself. And we're not going to necessarily have a solid number on the other side of that. So we're not going to have L equal to 5 or L equal to 3. But it will be an expression on the other side. But you just want to write that expression as simple as possible in lowest terms. And your goal is to get L by itself. So here on this side, I was just showing an example. If I have 7 equal to 2L plus 5, what would be my first move? And the first move here would be to minus 5 from both sides of my equation. So these variables represent numbers, and we treat these numbers or treat these variables the same way we would treat numbers. So that's going to be the same move that I will use here as well. I'm going to subtract this 2W from both sides of the equation. So 2W's cancel on the right, leave me with just 2L. And then on the left, P minus 2W is all I can do with that. So I cannot combine them. I don't have like variables. So all you can write is P minus 2W. To finish it off, get the 2 off of L by dividing both sides by 2. And here is our result. L is equal to P minus 2W over 2. Now we're going to talk about if you decide to go further with reducing this, the right and the wrong way of doing that, but make sure we are okay just getting right here. Any questions on that? All right, so there's a right and a wrong way to go further. Now you do not have to go any further with this problem because the 2 cannot divide evenly into both terms in the numerator. And I'll show you what I mean. I'll give you an example of it doing so in a second. But if you wanted to go further, what you cannot do is this right here. Notice it says incorrect. And the reason why I pointed out, because a lot of people will see those 2s and they'll be like, oh shoot, I can cancel out these 2s, cancel out the 2s, and then you have P minus W as your most simplified answer, and that would be incorrect. And that would be, a shame or messed up because you had the right answer, but then you went an extra step. Now you have the wrong answer, and you can't get correct get credit for the wrong answer, of course. And of course, there goes the bug man. So y'all, I gave y'all the heads up. Give me 1 second. I apologize. All right, guys. Sorry about that. I heard somebody unmuted. Did anybody have anything? Or that y'all were just okay. All right. So so back here, that's the incorrect way of reducing. So the correct way of doing so is right here. So whenever you have a denominator, you want to take that denominator and divide it into each numerator. You can't just give it to one. You have to give it to each one. So that 2 goes into the P, it goes into the 2W as well, and that's where you see right here. And now you can cancel out the 2's that's attached to the W, but notice there's still a 2 left in that P. So this expression right here is the same thing as this. So you can do that, but you don't have to if the 2 cannot go into each term. And notice P doesn't have a number in front of it that the 2 can divide into evenly. So it is okay to leave it like this. All right.
Will MathLab let you put either one in and it still be correct? Because I know it's super, super picky.
Yes, either one of those should be fine. And I'm glad you brought that up. But if there's ever a case you type in something and my math lab doesn't accept it, but you believe it is right, especially when it comes to tests. So I would encourage you guys to look at your tests, look them over, and make sure that everything was typed in correctly. For example, let's say if the answer is x equal to 2, or let's say the answer is 2, and you write x equal to 2. Well, if all they wanted was 2, they will mark that wrong. But I can give you credit and I can adjust the scores accordingly, but I won't know unless you tell me. Because I'm not going through every test, combing tests to try to figure out where can I add points. So I most definitely would need to know. All you gotta do is shoot me an email, say, Mr. Tucker, I did such and such test. And can you check this problem or that problem, whatever, and I can adjust the score accordingly. So yeah, most definitely. Yep. Questions on that? Everybody good on what I said? So now if you see over here in the green, I was just wanted to show you an example of when you must reduce. Like I said, here you didn't have to because 2 couldn't divide into them evenly. But right here, once again, it's a random example. It has nothing to do with the problem. So you say, where did 4 come from? It's a random example to show you, when you have to reduce. I see somebody say something in the chat. That's what it shows. Yes, when you go back to review, I don't know if it does it. I don't believe it does it immediately, but when you go back and click on your test to review it, it will show you the correct answer. It'll show you what you did and show you what the correct answer was. So in this type of situation, you are expected to reduce because the 2 can divide into that 4 and it can divide into the other 2 that's in the numerator. So like I said, you break it up by dividing 2 into each, 4p over 2, 2w over 2, and then that reduces down to 2p minus w. So just throwing that out there. All right, any questions? Any questions? All right, any questions? Everybody good? We'll look at another one. All right, so this next one, we have A equal to P plus PRT, and we want to solve for P. All right. So notice when we have this one, we have more than one P. You know, we have P in 2 different places, but we want to have one P. We want to have P equals 2. All right, so the way we can address that 2P situation is that we can factor P out of each one of those terms. And that's what I did here. I pulled P out of P, that leaves you with 1. If you take P out of that, you're left with 1. Then I took P out of the PRT, and that leaves us with RT. Don't forget, whenever factoring, if you were to multiply out back what you factored, it should give you what you originally had. So, you know, when I look at this, P times 1 is P times RT is PRT. So I can get back what I originally had if I were to do my distribution. So is everybody okay with that first step? Make sure we're okay. I factored out P from each one of those terms. All right, over here, we're just re-emphasizing the factoring process. That's all. So after that, you can divide both sides by 1 plus RT, that whole quantity of 1 plus RT. Divide both sides by that, because remember, your goal is to get P by itself. You have P times 1 plus RT. So now we divide both sides by that 1 plus RT. And our result is P is equal to A over 1 plus RT. Any questions? All right, any questions? Everybody good? We got one more down there. Just try to give you guys enough to look at when you're on your own reference. All right, so here we have A equal to 2LW plus 2LH plus 2WH, and we want to solve for H. All right. So notice we have H in more than one space, more than one place, just like we had that P. So we know at some point we're going to have to factor out H from each one of our terms that have H involved, because we want one single H. So we can have H equal to, you know, whatever our expression is. But what we need to do is get all of our terms with H on one side, all of our terms without H to the other side. So that's why your first move should be to subtract 2LW from both sides of your equation. That'll cancel out on the right and take it over to the left. So you have A minus 2LW equal to 2LH plus 2WH. So once again, what this does is it puts all of our terms with H on one side of our equation, all of our terms without H to the other side of the equation. All right, any problems? So now that we have this situation, we can factor out H just like we factored out P in the last one. That's what we did here. I pull h out of each one of those terms. So h out of that 2LH leaves you with 2L. H out of the 2WH leaves you with just the 2W. All right. Then we can divide both sides by 2L plus 2W. So we can get h by itself completely. And that's our answer. A minus 2LW over 2L plus 2W. Any questions? All right. Good to go, good to go. All right, so let's at least touch on 1.4 before we close out today. So we're looking at complex numbers. I probably should have made this different color, but it's all good. So 1.4 is complex numbers. We start off with the imaginary unit. And that is going to be the square root of -1. If you ever take the square root of -1 or square root of negative, the result is going to be I. Call that imaginary, the imaginary unit. So where that comes into play, when we look at, let me see if I can scroll up. Yep. Looking at this side, just taking the square root of a positive number. The square root of 25 is 5. That's because 5 times 5 is 25. Square root of 81 is 9. That's because 9 times 9 is 81. Square root of 121 is 11. Once again, that's because 11 times 11 will give us 121. But if I have the square root of a negative number, there's no number times itself twice that will give you a negative number. Because you see right here, -5 times -5 will still give you positive 25. So the way we represent this, taking the square root of a negative number, you can see the breakdown right here. You don't always have to write down the breakdown, but I'm just doing that initially so we can see where it comes from. You can take the square root of 25 and take the square root of -1 and represent and break it up that way. Square root of 25 is 5, but then we rewrite the square root of -1 as a symbol, which is I. All right. So that means the square root of -81 is 9I. Square root of -121 is 11I.
So are negative numbers automatically going to have an I after it for the
What?
answer?
Yes, the square root of a negative number, yes, will always have an I after it. Mm-hmm. All right. Any problems with anything so far? Let's scroll up. All right, here I also wanted to emphasize whenever you're taking the square root of a number that's not a perfect square, you are still expected to reduce it. Remember the first three we just did, they were perfect squares, so it's no big deal. But if you look at the square root of 18, that's not a perfect square, but you still can reduce it. The factors of 18 is 1 times 18, 2 times 9, 3 times 6. But when I look at which one of those factors can I take the square root of, I can take the square root of 9 evenly. So I can break up that 18 into 9 times 2, and then take the square root of 9 separately, which would be 3, and then leave the 2 under the radical. So this would be the most simplified way of expressing the square root of 18. So we take on the same thought process as with the square root of negative 24. It's just that a negative is involved, but we're still taking on the same thought process. We have the square root of negative 4 times 6 because I want to break up 24 into numbers, at least having one number that I can take the square root of evenly. And so that's why I use 4 times 6. So then the square root of negative 4 is going to give me 2i, and then I'll leave the 6 under the radical. So when I look at ways of expressing this answer, you can write it one of two ways. The first one, 2i square root of 6. That's the way I normally write it. Reason being is that when I write it, I don't have to worry about, or even when I put it in a calculator, I don't have to worry about my I being under the radical. But in the next way, 2 square root of 6 over I is fine as well. Just make sure you don't extend this radical over the I, because now you've created a whole nother problem, a whole nother expression. Let's see, somebody said something in the chat. No, either one of them should be fine. Yeah.
So I have a question.
Uh-huh.
So like with the square root of 18, you did the 3 there that equaled, 18. What if a number has 2 that can be evenly square rooted? Do you just go with the lower numbers? Does that make sense?
The highest.
The highest.
Yeah.
Oh,
So let's say if we have the square root of 500, I would break that up into 5 times 100, the highest one. But also in there is 25. That you could use. You could do what? 200 times 20? Yeah, 200 times 25. So, but I could take the square root of 25, but there's still more in there that I could. When it was 25 times 20. Yeah. Anyway, either way, 25 is still not the greatest number that I can take the square root of. So I will be looking at using the 100. And so what happened is if I break that up into, let's say 20 times 25, I probably should go 25 first. I'll take the square root of 20, 25. I have the square root of 20 times 5, which is fine. But I can still break up that square root of 20 into 4 times 5. So there will still be more to do if you don't choose the largest number. And so that's why you always look for the largest factor that you can take the square root of. And you'll still get the same answer. Like if I keep going, square root of 4 is 2. And then 5 times 2 is 10. So that's 10 square root of 5. But if I would have done it this way, can I go anymore? Yeah. Square root of 100 is 10. And that'll be 10 square root of 5. So either way, you'll still get 10 square root of 5 if you keep going. It's just that if you were to stop right here, my math lab wouldn't accept that as your answer because you can still reduce it further. All right. Hopefully that answered your question. Hopefully that's good. All right. Well, was anybody copying that? I don't know. I'm just scribbling. Everybody good? All right. All right. So your complex numbers are going to be a combination of your real part plus an imaginary part. So a plus bi will be a complex number, considered a complex number. And that's the standard form. Notice the real part is first, imaginary part is second. That is your standard form, a plus bi. They are going to expect you to write your answers in standard form, whether they say it or not. So you always write your real part first, then your imaginary. Over here in green are just examples of complex numbers. 2 plus 5i, negative 1 plus 3i, 7 minus 10i. The number 8 itself could be considered a complex number. That's 8 plus 0i. Or negative 12i is also a complex number because you can write 0 for your real part, then minus 12i for your imaginary part. All right, any questions? All right. So when it comes to adding and subtracting complex numbers, all we are doing are combining our like terms. So real parts plus real parts, imaginary parts plus imaginary parts. So here we have 5 minus 11i plus 7 plus 4i. 5 plus 7 is 12. Negative 11i plus 4i would be negative 7i. Got left already? Okay, all right. Right here, negative 5i plus negative 5 plus I minus negative 11 minus 6i. So whenever you're subtracting your quantities, your expressions, you know, as you always do, you should distribute the negative first. So that's what we did right here. So that negative has to be applied to each term that's in the parentheses. So that's why we have a positive 11 and then positive 6i. After you've done that, you can freely combine your like terms. Negative 5 plus 11 is 6. And then I plus 6i will be 7i. Any questions? Any questions? Scroll up. Last thing we'll do for today is multiplying your complex numbers. Everybody good with the add and subtracting? Okay. Let me erase some of this stuff. Let me get that up here. See what part I want to keep, where I want to start. Okay. So first thing we're looking at is distribution. We have 4i times 3 minus 5i. So just like we would if we didn't have any imaginary numbers involved, we're going to distribute. And we'll distribute the 4i and multiply that times each term in the parentheses. So that's going to give us 12i minus 20i squared. So now I squared cannot be a part of your final answer, and because you can still break down I squared more simply, and that's what I have right here in this blue, is that we know I is going to be equal to the square root of negative 1. So if I were to square that, the square and the square root will cancel out, and that will leave you with just the negative 1. So not saying you always have to break that down like that. I'm just showing you what happens. So what you need to hold on to is that whenever you have I squared, that is negative 1. I squared always reduces down to negative 1. Like I said, I was just showing you the breakdown there. But I squared is negative 1. And so that's what we have right here, 12i minus 20 times negative 1, because that I squared turns into negative 1. Everybody all right with that? We have 4i times 5i. 4 times 5 is 20. I times I is I squared. I squared will always reduce to negative 1. All right. So then that negative 20 times negative 1 is going to give us positive 20. And then you want to write it in standard form. Remember, the real part's first, imaginary part is second. So you write 20 plus 12i. Any questions? All right, next one, 7 minus 3i minus 2 minus 5i. So we're going to FOIL, distribute each one of our terms. So that's 7 times -2, 7 times -5i, then -3i times -2, -3i times -5i. And we have this here. What is going on? All that noise. Okay. Sorry, y'all. Just teaching from home, man. It's always some stuff going on in the neighborhood. So -14 minus 35i plus 6i plus 15i squared is our result of that binomial distribution. So we'll combine our like terms in the middle. That -35i squared plus 6i squared, 35i squared, -35i plus 6i will give us -29i. And then don't forget that I squared is going to be -1 for us. So 15 times -1 is -15. So we go ahead and finish off by combining our like terms, -14 and -15. It's -29 minus 29i. All right, any problems? Any problems? Everybody good? Hold on one second. Let me see if I'm multiplying those. Nope. Okay, so what we can do is start right here, next class with the complex conjugate, telling y'all so that just in case I forget, somebody remember that we're starting right here with the complex conjugate. And that'll take us into division. And then we have one other thing. Yep. And then we'll go into 1.5. Okay, yep. So this is where we'll start next class. All right, any questions, concerns, comments before we close out for the week? Everybody good? All right, straight.
What homework are we like ready for?
1, 2, and 1, 3, and some of 1, 4, the first part of 1, 4. Yeah. So really up to multiplying complex numbers in 1, 4. So once it mentions division, we haven't done that yet. That's the next thing we're going to do, divide these complex numbers.
So we should do the part 1, part 2, and part 3 right now, though, right?
Mm-hmm. Yep. Be a good place to go ahead and get started. Anybody else? Everybody good?
Are you setting a due date for these homework assignments yet?
Have not set them yet. I'll probably put that due date out there once we get into 1.6, kind of gauge where we are and what will be a good date for that. But yeah, I normally put due dates out as we come closer to closing out the chapter. And I give you enough time. It's not like I'm gonna be like it's due tomorrow. Like, I'll give you, a week or so to go ahead and knock that out.
Thank you.
Yep, not a problem. And with, that's a good question. And then with that, when I put a due date out there, it is with the assumption that we are doing work, before you hear the due date. So in other words, if we get to 1.6, because we're still gonna have 1.7 and, to talk about and stuff like that, and then make sure you guys are ready for that test that you're gonna take. I am assuming that you have been doing 1.2 and 1.3, you know what I'm saying? So I don't anticipate that, okay, I put a due date out here and you haven't done any work at all, because that due date, is really for, okay, I'm up to a certain point and I'm ready to close out this chapter. So, just throwing it out there, make sure you guys are doing this work as we progress forward. And then if you come across, a due date, you didn't get stuff finished or whatever, do not just take L's. Make sure you contact me so we can see what we can work out as far as making sure you're straight. If you need an extension, all that stuff, but that type of stuff you do ask individually. So I always try to make sure my students are set up even beyond me. If you have an individual situation, you always ask the professor individually, because if you ask during the class setting, you're going to get a class answer. You know what I mean? So I always say that if you have a situation that you're trying to get an individual answer for, you always ask the professor individually, so you can get an individual answer, that pertains to you versus a class answer that may not be the best suited for your situation. So always feel free to shoot me an email or something of that nature, so we can make sure you're straight moving forward. All right. Anything else? Anybody else before we close? All right. So you guys have a great weekend. Be safe. Take care, and I will see you on Tuesday.
Have a good weekend.
Thanks. You
Hi,
do the same.
Professor.
All right. Take care. Thanks. Have a good one.
Have a good holiday.
Thanks. You do the same.